Hello everyone, welcome to Networkers Home. Today I am here to discuss about 25 interview questions based on the routing. So the first question, what is static routing and what is default routing? What is static and the default routing? So static routing is what it is a method in which the routes are manually added by network admin and it is done based on the known address. It means what that in a static routing, we will be knowing the addresses. And which address? Destination address, where we have to reach. That addresses will be known to the network admin. And that we have to specify in the commands. Now, whereas in the default routing, what happens that it is done with the help of unknown address. So in this, what happens? It is with the help of unknown address, means we can say with any address with any subnet mask. So for example, if you are specifying the IP route command for default routing, so you will write IP route to reach any network with any subnet mask. Then we will go with what? Exit interface number and the next hop IP address. This is a complete statement, or you can say complete command that has to be done for the default routing. So that's why in the static that is based on the known address, whereas in the default routing is based on the unknown address. Next, what is that AD value of the static routing? So AD is what? AD stands for administrative distance. So AD value of the static routing is 1. So in the coming slide, I will discuss what is that AD values. It is present there. So the AD value of the static routing is 1. Now, the next question that we have is why do we prefer this fully specified static routing? See what happens that whenever we are going to specify the routing for the static node, so there are multiple ways of doing that. So we can go with the help of this exit interface number, where this method is called as a directly connected method. In this, what we specify, we used to give command IP route, then the network address, or we can say the destination network address where we have to reach, subnet mask, and here we used to give the exit interface number. So if we give only exit interface number, no, so here we have a problem of the ARP. Each time what happens, the packet is being generated and it is going to require what? ARP packet will be generated for that. So to overcome with that, what we have? A fully specified static routing. One more method we have of doing this static routing, where we have to give IP route, same network address, then subnet mask, and at last we will give here what? Next hop IP address. And in this type of static routing command, the problem is recursive lookup. Means router has to check its routing table 2 times to reach that particular destination. So in this we have a problem of ARP, and here we have the problem of recursive lookup. So to overcome with that, we have a fully specified static routing that is preferred to overcome the demerits of the directly connected static routing and even the routing based on the next hop IP address. So what is the command says? It says that IP route, network address, subnet mask, exit interface number, and the next hop IP address. This is the complete or fully specified static routing command. Next, after this, we have the third question, that what is null static routing? See, null static routing is a type of routing in which where the destination is intentionally discarded, and it is also called as a static route to a null zero. Now, what is this null zero? This is null zero interface. So in this, what will happen now? Even for example, if we have done the routing and all the network is reachable, let's say this is R1 and R2, and we have this side n numbers of different network based on that loopback interface. So when we have done the routing, so all the network will be reachable. For example, let's say we are going with the default routing. So all the network is reachable now. Now we have to filter one of the network that this should be discarded. It should not reach there. So we can go with what? Null static routing. Even this null static routing is preferred to avoid the formation of loop. So Here what will happen? The routing will be done with the help of what? Null zero interface. That is called as a null static routing. And why do we have this? To intentionally discard our routing packets. Next, we have the fourth question, that is, what are the limitations of the static routing in the large scale enterprise network and how they can be mitigated, how we can overcome with that limitation of the static routing. So it is telling you that it is based on the manual configurations and maintenance. So every time it is based on manual configuration and even the maintenance means it is going to change all the things only when any admin is going to update the change. So it is not going to change automatically. That's why it is based on the manual configuration. It has lack of scalability. It cannot be supported in a large network because it is having like it we cannot means use the static routing in the case of large network where we have lots of different devices. Then it do not adapt automatically to the network changes. So it is manual. So dynamic routing can be used to overcome the limitations of the static routing. So these are the limitations we can see, like manual configuration, maintenance, lack of stability, do not adapt automatically. So to overcome with that, the limitations of the static routing, what we have, the concept called as a dynamic routing. And we know that this dynamic routing has been divided into two parts. One is what IGP and one is what EGP. IGP is what interior gateway protocol and EGP is what exterior gateway protocol. So some protocols comes under the IGP, some protocols come under the EGP. So examples of the IGP will be what? And the dynamic routing, like for example, we have OSPF, then EIGRP. Okay. Now in the EGP, what we have? We have BGP, border gateway protocol. Even in the IGP, we have some more protocols, but that is not being used. Like for example, we have RIP, we have IGRP. It is not being used. Apart from that, we have one more protocol, IS. So these are all the protocols comes under this dynamic routing. Next, the fifth question that we have is based on one of the topology. So here what happens that we have taken here router 1, router 2, router 3 and router 4. With this router 4, we have taken one PC. Here we have 12.0 network. Here we have 23.0 network. Here we have 13.0 network. Here we have 34.0 network. And here we have 40.0 network. Now from the router 1 to reach this particular PC, let's say this PC is having IP is 192 or 168.40.1/24. Now to reach this PC, this router one has two ways. It can go via this one also. It can go via this one also. It can send the traffic by this one also, via this one also. Now in this scenario, what we have done here static routing. Here also we have done the static routing. Now if both the place we have done the static routing, what will happen? The router will consider both the path as a best path. In this case, it does load balancing. It does load balancing. Now we want that no, it should not do this load balancing. What it should do, it should prefer only one path at a same time, at a one time. So for that, what option we have? The option we have is that we can increase the AD value of one of the route. Now we know that for the static routing, the AD value is what? 1. So here also if AD1, here also AD1, both the path is best now. So what we'll do, we will change the AD value of the one of the route. Let's say we are changing for the first route, we are making it as a AD value as 5. So now we know that lesser the AD value is considered to be most trustworthiness of the protocols. So now what will happen now, even if it is having higher AD value and it is going to have by default AD value as 1, so this router is going to consider this part as a best path. And this will be taken as a path for the routing purpose, not this one. So how we can change this AD value? For that, just the command that we have to add here, IP route, and we used to give network address if we are preferring fully specified. So we will also write here subnet mask as well as exit interface number. And then at last, what we will write? Next hop IP address. And in front of that only, at last, we will add one number higher than the 1, because then only it is going to have the best path. So let's say we are going with 10 or 5, anything, 10 will. So if you have added here 10, so what will happen? The AD value of this route will be changed to the 10. And now this one will be considered as the second path, and this one is the best path. So when we will check the IP route table now, so in the IP route table, always the best path is present. So this will be present. Once this is not available, then it will change the path and it will use this path as well. But when this path is not available, then. So what it is saying, that if you are using a static routing to reach the same destinations, so we have multiple paths. Now on both path we have used static routing. Then what will happen now? Which path will be taken and what options we can use, where router only means like it considers only one path to send what? Data packets. Okay, for that we have these options. And this term is called as a floating static routing. Floating static routing. Fine. Next. After that, we have questions based on what is the differences between static routing and dynamic routing. See, static routing, we discussed that it is based on what? Manual configurations. So here routers are manually entered by whom? By network admin. And it has one fixed path. So once the configured, so routers do not change until and unless it is manually updated or manually changed. So it is always manual. Okay. Now, where do we prefer this? It is best for small network. Ideal for the simple and stable networks with what? Where we have a predictable traffic patterns. We know where to send. We know the addresses. Now, automation path selection. See, routers can learn automatically. This is regarding what? This is regarding the dynamic routing. Till this one, it is for static routing. And it is automation path selection. Routers can learn the routes automatically by using OSPF, EIGRP or BGP. This is regarding the dynamic routing differences between static and dynamic. So it is telling you that the routers can learn automatically under which? Under the dynamic routing using what? Using the protocols like OSPF, EIGRP or BGP. Then it adapts to network changes. Means automatically it is going to update the routing tables when a link goes down or a better routes become available. Whenever any alternate path is available, or let's say for example, the route that we have specified or not we have specified, it is finding automatically. Now if it is not working, so he has to find its backup path automatically based on this routed protocol that we have used. So where do we prefer this? It is better suitable for the large network and the complex networks. So used in the enterprise and the ISPs for scalability and for flexibility. So this is the differences between the static routing and dynamic routing. Next, the seventh questions that we have is why do we use this AD, that is administrative distance value or AD value? See, administrative distance is a numerical value that is used by routers to determine what? The trustworthiness or preference of a routing source when multiple routes to the same destination exist from different protocols. And here what happens? The lower AD value has the higher priority. For example, let's say you have a router 1. Now to reach, on this side we have a router 2 and this side we have a router 3. To reach this network, this router 1 on this interface, let's say we have done a static and here we have done OSPF. This side we have done OSPF. It is having an AD value of 110. It is having an AD value of 1. Now this is having the least AD value, no? So whenever the route will be done, so it will be based on the static routing. When you will check the IP route table, no, it will show you static. Why? Because it is going to have lesser AD value. So that's why the same thing it is telling you that it is used to determine what? Trustworthiness or preference of a routing sources when multiple routes to the same destination exist. To reach the same destination in this scenario, we have multiple routes, but he has to consider only one route. And how it is considering that route? Based on that particular AD value. That's why we have the use of this AD values. And all the routing protocols that we are going to discuss or we will be discussing, it is going to have certain AD values. Different routing protocols, different AD values. Next, the eighth question. See, I told you that this dynamic routing has been divided into IGP and EGP. So there can be a question, what is the differences between IGP and EGP? So IGP stands for Interior Gateway Protocol, a routing protocol used within a single autonomous system. Then it is called as a IGP. EGP is what? Exterior Gateway Protocol, a routing protocol that used between different autonomous systems. So within same autonomous system, it is IGP. Between different autonomous system, it is EGP. What is this autonomous system? It is a grouping of devices that is managed, configured, and administered by a single organization that is called as a autonomous system, and each autonomous system is going to have a ACE number. So we can say that a grouping where multiple devices is being managed by, configured by, and administered by a single organization, so it can call as an autonomous system. What can be the example? Example can be any single organization, like for example ISPs. Internet service provider can be the example. Any other organization we can say. It is also one of the example. So it is going to have what? AS number. Fine. And based on that, we have IGP or EGP. Now, in this IGP, we have a concept called as a distance vector. So some of the protocols coming under this IGP is going to use this distance vector as a metric to calculate the best path. So example of the protocol that it is going to use distance vector, a routing information protocol, interior gateway routing protocol. Fine. So these are all the protocols that is using distance vector as a metric to calculate the best path. Even EIGRP. See, EIGRP uses two things: distance plus link state. And apart from that, it has certain K values to determine the best path. So it is called as a hybrid protocol. This EIGRP is not a completely distance vector protocol. It is a hybrid protocol. And it is an enhanced version of what? It is an enhanced version of interior gateway routing protocol. Now, what is distance vector? Distance vector is a type of routing protocol that determines the best path to a destination based on what? Based on the distance. So, to reach a certain destination, how many routers that router has to cross? For that, he is going to calculate the distance. So, distance is one of the criteria to find the best possible path. Apart from that, here, what does this vector represent? Vector is where the distance means how far the destination or destination, and vector represent what? The direction of the distance. So for example, if we have a router 1, he has to reach, or we have to send certain packets to router 2. So it has to go via this distance, and this is the vector, this is the direction it has to follow. It cannot send it information with this interface, because he has to send it to the R2, and R2 exists this side. So that's why he is calculating two things: distance also It is calculating two things, distance plus what? Vector, that is direction. That is, we can say, distance vector. Now, next that we have is a 10th question. How does this OSPF determines the best path? See, OSPF determines the best path with the help of link state. With the help of link state, it is going to identify the best path. Now, here, what does this link means? Here, the link means we can say how the device is connected. Link means interface of the devices, how it is being connected. And state means what? Like we can say whether that state is up or down. If it is up or down, what is the bandwidth it has? What is the delay it has? So this is all the information you will get from the state. So this OSPF open shortest path first, it is a link state routing protocol that uses shortest path first algorithm, also known as Dijkstra's algorithm, to determine the best path to our destinations. And for that, it is going to have a cost. Cost is equal to reference bandwidth upon interference bandwidth. It is going to find the best path with the help of one cost, where cost is equal to what? Reference bandwidth upon interference bandwidth. Next, the 11th question that we have is, what is router ID? And what is the use of this router ID in the OSPF? See, router ID is a 32-bit unique identifier that is assigned to each router participating in routing protocol. And it is used to uniquely identify the router with the routing domain. Now, what is this router ID? It is a 32-bit identification number. How do we get this? There are different methods of getting this router ID. First is what? Manual. Manually, we are configuring the router IDs on the routers. Second, it can get it automatically. If automatically, then how? In the automatic only, we have two criteria. The first one says that the highest IP, where the highest IP on loopback will be what? Will be the router ID. This is the second, like automatic criteria for the first one. Now, if we have not configured any IP address on any of the loopback interface, then it will check it from the highest IP on any physical interface. So first criteria, it is checking for the loopback interface. If there is no any IP address configured on any of the loopback interface, so it will check for the highest IP addresses configured on any of the physical interface. And that IP will become the router ID of that particular router. And in the OSPF, we need to have different router ID on the router. This is not required in the case of EIGRP. In EIGRP, even if the router ID is not same, neighborship will form. Means even if the router ID is same, then neighborship will be formed. Whereas in the case of this OSPF, it should have unique router ID. This is the use of this router ID and how, like, this is how we can get the router ID. And it is like what? 32-bit. How do we have IP version 4 addresses? It is similar to like that only. Now, next question that we have is, what are the different types of OSPF area we have? See, in the OSPF, we have one area that is called as a area 0. And this area 0 is called as a backbone area. And the router belonging to this particular area 0 is called as a backbone router. So different types of area we have in this OSPF, like backbone area, standard area, stub area, totally stub area, not so stubby area. Then we have totally an SSA. So these are the different types of OSPF area. If you are interested in to know about all this types of area that we have, so you can comment, we'll make a separate video for that. Now, what is the role of DR and BDR in OSPF? DR is what? Designated router. BDR is what? Backup designated router. Why do we have this? See, what happens in the OSPF domain, a router used to send messages like updates in the form of LSA, link state advertisement. And each neighboring router used to update its own neighboring router with the help of this LSA. And this cause what? This cause LSA flooding. We have to control this LSA flooding and we have to limit this LSA flooding. For doing this, we have a concept called as a DR and BDR. And this DR and BDR concepts also come under network types, where we have broadcast multi-access network and where we have non-broadcast multi-access network. In all the network types in OSPF, we don't require this DR and BDR elections. It depends upon the network types that we have taken. Based on this network type, this DR and BDR election is required. And here what happens, that DR is acting as what? Act as a central point for the OSPF adjacency. And now what will happen, that all the routers present in the network, if anything has been changed with them, so he has to update that change to whom? To the DR. And this DR way is going to update these changes to all the router. So it is not that like only all the router will be updating to the neighboring router. No, they have to update to the DR, and now DR will update to all of the routers. So LSA exchange on the network. Now, why do we have this BDR backup? If DR is not present, then who will take place? BDR, backup DR. So it takes over the DR if DR fails. It listens to all update but does not forward the LSAs unless the DR is down. So even it will receive the information, but it will not forward until and unless this DR is not working. This is the concept. So how do we get this DR and BDR? From where? Like, what is the criteria to have this DR and BDR? See, the router with the highest priority number will be the DR, and router with the second highest priority number will be BDR. Now, if by default on all the router the priority number is 1, then this election will happen based on the router ID. If priority number is same, then in this scenario what will happen? The router with the highest router ID will be DR, and router with the second highest router ID will be BDR. And whatever the other router that is left is called as what? Is called as a DR other. So DR, BDR and DR other. This is how we can have this DR and BDR election. Now, what is LSA and what are the different types of OSPF LSAs we have? Even we have different types of LSAs. So in that, LSA stands for what? Link state advertisement, that is used by OSPF routers to exchange information about the network topologies. So in this we have router LSA, a network LSA, a summary LSA, a SBR LSA, that is autonomous system border router LSA, AS external LSA, and NSSA, not so stubby area external LSA. So I have made a separate video on this particular types of LSA. You can go through that. Next, 15th questions that we have. What authentication methods does this OSPF support? See, one we have is a plain null authentication. In null authentication, that is type 0, where we can say no authentication. If no authentication is done, then we can say it is null authentication. Next we have is a plain text authentication. That is type 1. Here what is done? Here we have given plain text, or we can say clear text password. That is visible. That's why it is plain text password, type 1. And third we have, here we have encrypted password. How we are going to encrypt that? Based on hashing algorithm like MD5 we have, message digest 5, SHA, HMAC SHA-256 we have. So this can be used for authentication purpose. So three criteria of authentication in the OSPF. One is null, that is no authentication. Plain text, where the password is visible, clear text it is. And authentication type, where it is going to be encrypted. Now next we have, and even in the OSPF, there is one neighborship criteria. In that neighborship criteria, authentication must match between the router, then only the neighborship will be formed. Okay, you have to go through all the neighborship criteria in the OSPF. Even it is there in the EIGRP, how to form the neighborship. Next we have 16th question. What are the criteria to form neighborship in EIGRP? Question. What are the criteria to form the neighborship in the EIGRP? So router must be in the same EIGRP autonomous system. Means autonomous system number should be same. Then only the neighborship will be formed. So what if the autonomous system number is not matching, not same, then also neighborship will be formed, but their redistribution has to be done. Then only the neighborship will be formed in that scenario. Next, it says that K values, that is metric values, should match. Like it is having certain different K values to calculate the best path. K1, K2, K3, K4 and K5. Then authentication, if we have configured any authentication, it should match. Then only it is going to form the neighborship. Then interfaces must be in the same subnet. It should not be in the different subnet. Like if for example we have a router 1 and a router 2 and we have to form the neighborship between them, so they should belong to same subnet, not different subnet. EIGRP must not be passive on the interface towards the neighbor. For example, let's say if this router 1 has to form the neighborship with router 2. So what this router 1 will do, it will advertise the network information with this interface. Now if this is passive interface, what will happen? It will not form. So it should be what? Active interface. So where we can have this passive interface? If for example with this interface we have connected one switch and with that end device we have connected. So we can make this interface as a passive. Why? Because it does not require any information to form the neighborship. So we can make it this interface as a passive. See, one interface can be made passive in two ways. First, by default, not on the interface, one device. Let's say we have a router. On router, we can make multiple interface. Let's say, for example, multiple interfaces present on this router. And I want to make all the interface as what? Passive. So I can go with what command? Passive interface default. Now I want that only single interface on this router should be passive. Then I will go with the command what? Passive interface and that particular interface number. So two ways of making one of the interface as a passive. With the help of global command, that is go with passive interface default. So on the router, whatever the interface that we have will be all passive. Second option we have that go on the individual interface and make it passive. Like how this is done. So next 17th question. What is successor and feasible successor in EIGRP? See, whenever like this in the EIGRP, based on this K values, it is going to identify the best path. So based on that, successor is what? Successor is the best next hop route to reach a destination. So this is the best path we can say is called as a successor. Then we have is a feasible successor. It is what? It is a backup route that is guaranteed to be a loop free. When we use, it is used for faster convergence if the successor fails. So if the primary route fails, then only this secondary comes take place, that is a feasible successor. So there is a one conditions to have this feasible successor, and that is called as a feasibility condition. We have feasibility condition. Based on that feasibility condition, this feasible successor take place. And you have to verify what is this feasibility condition. Next, the next question is only there, that what is explain the feasibility condition in the EIGRP. So for a route to be considered as a backup route, that is feasible successor, the reported distance received must be less than what? Feasible distance calculated locally. So reported distance, that we can say RD, must be less than FD, that is feasible distance. And this reported distance can also be called as what? Advertised distance. So it should be less than what? It should be less than the feasible distance. Then it is going to be a backup path, or we can say feasible successor. This is what feasibility condition. So in this we have certain more terms. What is successor? What is a successor route, like we have discussed. So this is successor, the next hop router to reach a destination. And feasible successor is what? That is a backup best second path. See, successor, this is not successor route. Successor route is the best path. You have to be very clear with the terms here. Successor, it is successor, not successor route. Successor route is the best path. Fine. This successor is what? This successor is the next hop router to reach a destination. So this successor route will be called as a best path, and feasible successor will be called as a backup path. And if the primary successor route fails, then only this feasible successor comes or take place. Fine. So this is successor and feasible successor. And this is what we discussed about the feasibility condition. Next we have, how does EIGRP support unequal cost load balancing? See, to support this unequal cost load balancing, this EIGRP uses variance to enable unequal cost load balancing. And what is this variance multiplier? It is feasible successor of feasible distance of the feasible successor, and feasible distance of the successor route should be less than or equal to this variance multiplier. And whatever the number that we are going to get, that we are going to implement with the help of one command, variance. And here we have to add here that multiply that we have got. And based on that, it is going to do what? Unequal cost load balancing. So based on this formula, what we will get? We will get a new FD. New feasible distance we will get. And based on this new feasible distance, we will be having multiple backup path. And for that, it is going to do what? Unequal cost load balancing. Next, what is that? SIA query and SIA reply. See, what does it is SIA means? Stuck inactive. So it is a condition occur when a router does not get reply to its query about a route. For that, it sends a SIA query and get a SIA reply. For example, let's say we have a router. It is having one network information 1.1.1.1. It has advertised with its navy router as well. Now, this information now is missing with the router 1. So what does router 1 do? It sends a query packet to whom? To router 2, asking for do you have this information or not. Now what happens? Let's say if this router 2 is not replying, so within 90 seconds, if it does not get any reply, no, so for that it sends SIA query packet. And if he sends SIA query, then he will need a SIA reply. So it is in this SIA query, it is asking to router 2 that still are you stuck in the query that I have given to you earlier? This is the question. So same thing, it is going to reply with the SI reply that it is stuck in that particular active state only. So we have an active timer in the case of that particular EIGRP, that is 180 seconds. So it is a condition occur when a router does not get a reply to its query about a route. For that, it sends a SIA query and get what? SIA reply. So this is the questions we discussed till here regarding a static, OSPF, EIGRP, and some of the terms related to dynamic routing. Now we have BGP. 21st question. What are the differences between iBGP and eBGP? That is interior border gateway protocol and exterior border gateway protocol. So BGP sessions between the routers within the same autonomous system is called as a iBGP. Whereas BGP session between the routers in different autonomous system is called as a eBGP. One is iBGP, one is eBGP. Now, 22nd question, what is that? What is the BGP path selection process? And list the attributes in order of preference. See, in the BGP, it is going to have path attributes. And based on this path attribute, it is going to have the best path. It is a selection process. In this, some of the attributes I have written here, like what is that? Highest weight, it is a Cisco proprietary. Highest local preferences, locally originated routes, shortest AS path, lowest origin type, what is that? Lowest multi-exit discriminator, and eBGP prefers over this iBGP paths, and lowest IGP cost to next hop. Like if you are interested in to know about this all this attributes in detail, so please comment, we'll make a separate video for that. Now 23 questions what we have. What is the purpose of a BGP confederation? Why do we have this BGP confederation? See, a BGP confederation is a technique that is used to divide a large autonomous system into multiple smaller sub-autonomous system. So large autonomous system we are dividing into what? A smaller sub-autonomous system, while is still presenting itself as what? A single autonomous system BGP pairs. For example, if we have a router, we have a AS number in that is, for example, 100. Under this, we have certain different routers. Let's say some of the routers in area AS number 1, some of the router in AS number 2. What we are doing? We are dividing it. And we have one more router that is outside of this AS. So when this router will get the information regarding this R1 and R2, no, so it will not get it from AS number 1 or 2. No, it will get this AS number as 100 only. For we can say for representing the outside routers, always this AS will be preferred. That is called as external AS. Whereas this one is what? Internal AS. So this is we call it as a BGP confederation, in which what we are doing, we are dividing large autonomous system into small different AS numbers. That is why with the help of that, what will happen? The iBGP that we have will be divided and will be made to act as what? eBGP. Why do we have this? To overcome with the mesh. To overcome the full mesh adjacency or full mesh topologies, we are going to have this iBGP. Same, one more we have in this. Route reflector. See, what is this BGP route reflector? Why it is used? So a BGP route reflector is a router within an autonomous system that reduces the need for a full iBGP mesh by reflecting BGP routes learned from one BGP pairs to other BGP pairs. To reduce this particular iBGP mesh only, we have the concept called as a route reflector, in which we will be having certain router as a client, non-client, like that. And the last question that we have is, how does BGP prevents this routing loops? So BGP prevents this routing loops between different autonomous systems by checking what? AS path attributes, and BGP avoid this loop using what? A full iBGP mesh, that is like this. It is going to avoid by how? Using this route reflector. So this is all 25 interview questions based on the routing. So if you are interested in such type of videos, so please like, subscribe, and we'll see you in the next video. Thank you.